When we look at that energy flow, specifically looking at heat and work, we need to have some sign conventions. What does it mean when heat or work is negative? What does it mean when heat or work is positive? First, let's look at work. When we have work that's being done by the system, so the work system doing work on the surroundings, what we're going to see is that that value is negative. If work is being done on the system, then that work is positive. For example, when we look at a pitcher throwing a baseball, we're defining the baseball as our system because remember, we define the system. Work is being done on the system by the surroundings. So I'm the surroundings, the baseball is the system. I'm doing work on that baseball, therefore it has a positive value. So the work being done to that baseball is positive. When we're inflating a balloon, and the balloon is our system, work is being done by the system on the surroundings. Because remember, as that balloon expands, it's pushing outward. And we'll see that this is called PV work, and we'll look at some examples of that later on. But what we're going to see is that it's expanding and pushing on the surroundings. So it's doing work on the surroundings and has a negative value. For heat, what we're looking at there is heat is the transfer of thermal energy due to temperature differences. If I have a glass of ice water, the ice is one temperature, the water is a different temperature, and I mix them together, and if I let them sit, what's going to happen is heat is going to flow from one to the other until they're at the same temperature. But the heat flows because there is a temperature difference. When we look at heat and talking about what's going on there, we see that when heat is going from the system to the surroundings, so heat is leaving the system, okay, so heat is going to the surroundings, that's a negative value. We also refer to this as exothermic. And when we talk about exothermic, what we're saying is heat is exiting the system. So exiting, exothermic, negative value. When the system gains heat, so heat coming from the surroundings into the system, the system is gaining energy, heat is going into it. We call that an endothermic process, and it's going to have a positive value. So heat going in versus heat exiting. So X and endothermic are talking about the flow of heat as well. For an instant cold pack, we see heat is being gained by the system. It's going to be positive. For these cold packs, typically there's a smaller container inside the larger packet. You break that, releases a compound in there, so now we start a chemical reaction. And that chemical reaction is consuming heat. And we don't produce cold, we consume heat. And so the heat goes from the surroundings into the system for that reaction to run. And that's why it feels cold, because the heat is being used up in order to run that chemical reaction. Let's look at burning wood, where the wood is our system. As it burns, heat is being lost by the system into the surroundings. That's what gets us warm. And so we have a negative value. So the heat is exiting the system. This just summarizes the sign conventions for heat and work going in and out of the system. Okay. So from the system, which is our box here in the middle, into the surroundings, which is everything else, we see we can have a negative or positive Q and a negative W or a positive W. And they can be a mix and match situation. Just because one's negative does not mean the other one is negative. Let's look at an example. A system gains 165 joules of heat and does 92 joules of work on the surroundings. What are the signs of Q and W? We see that we're gaining 165 joules of heat in our system. Therefore, we have a positive value of Q. And then we're doing 92 joules of work on the surroundings. So we have a negative value for work. Therefore, B is our correct answer. Q is positive and W is negative.